Using Excel for Goodness of Fit Tests. This video uses example 1 from section 11-2 titled Last Digits of Weights. The Excel function CHISQ.test or CHI test and the Excel stat add-in can both be used to find the p-value for goodness of fit tests. But only Excel stat also provides the test statistic. For this reason, Excel stat is recommended. In this video, we will begin with the procedure for Excel stat, followed by the procedure for the Excel function. Excel stat can be used to calculate the test statistic and p-value for goodness of fit tests when the frequencies and expected frequencies or expected proportions are known. Excel stat requires integers for frequencies and expected frequencies. If the expected frequencies are not all integers, as often happens, you must input the expected data as proportions. Begin by clicking on the Excel Stat tab in the ribbon. If the Excel Stat add-in is not installed, refer to Elementary Statistics Using Excel 5th Edition, Section 1-5 for installation instructions. Click on the Parametric Tests button and then select Multinomial Goodness of Fit Test from the drop-down menu. You should now see the Multinomial Goodness of Fit Test dialog box. In the Frequencies box, enter the range of cells containing the observed frequencies. In this example, we have entered the 10 observed frequencies in cells A1 through A10. In the Expected Frequencies box, enter the range of cells containing the expected frequencies. In this example, we have entered the expected frequencies in cells B1 through B10. Expected proportions can also be used in this step by checking the Proportions box under Data Format. On the bottom right, enter the desired significance level. In this example, we enter 5 for a 5% significance level. Check the chi-square test box. If the data range includes a data label, check the Column Labels box. In this example, there is no data label, so we leave this box unchecked. Select Sheet to display the results on a new worksheet. Click OK, and the results will be displayed as shown. The test statistic chi-square is labeled chi-square observed value. In this example, the test statistic equals 212.8. The p-value can be found below that. In this example, the p-value is less than 0.0001. If we use the p-value method of testing hypotheses, we see that the p-value is small, less than 0.0001, so we reject the null hypothesis. If we use the critical value method of testing hypotheses, we find that the test statistic of 212.8 is greater than the critical value of 16.919. Because the test statistic falls in the critical region, there is sufficient evidence to reject the null hypothesis. In other words, there is sufficient evidence to support the claim that the last digits do not occur with the same relative frequency. To use Excel itself, rather than Excel stat for goodness of fit tests, begin by clicking the Insert Function button, then select the category of Statistical in the Insert Function dialog box. Scroll down and click on the function name of CHISQ.test or CHI test, and then click OK. You should now see the Function Arguments dialog box. In the Actual Range box, enter the cell range of the observed frequencies. In this example, we enter A1 through A10. In the Expected Range box, enter the cell range of the expected frequencies. In this example, we enter B1 through B10. Click OK, and the p-value will be displayed. As a reminder, Excel itself does not provide the test statistic chi-square or critical value.